Can you tell me what is computer vision and biometrics? What's it all about?
Computer vision is about analyzing images from video cameras, and it has many applications. For example, an electric car nowadays is able to drive itself on a road, and it means that it has to analyze the images that come in. So analyzing images and drawing conclusions from those images is basically what the field of computer vision is about.
In day-to-day life, we are using a lot of biometrics like the eyes, the iris, the fingerprints, and your face as a whole. When you take your mobile phone, you have to use biometric for each and everything in it. Use your fingerprint for unlocking it, you use your face for unlocking it.
Now, we do research in computer vision and biometrics, and that means that we try to, on one hand, develop better and new methods for person recognition, and on the other hand, also try to develop systems that can be explained how they work. So it's not just a decision by a black box, but we try to design systems that we really can explain.
I did my bachelor's in electrical engineering. When I wanted to do master's in electrical engineering, here at the University of Twente, there are a lot of options. Like you have a lot of specializations. It's actually very diverse.
You probably have heard of deepfakes, for example. Never heard of deepfakes?
I've not heard of that.
You can have an actor saying things and it looks like if the politician is saying these things. And you can also synthesize the sound.
Moving forward, we need to be more vigilant with what we trust from the internet. That's a time when we need to rely on trusted news sources.
So we do develop methods to detect these manipulations. And there are many types of different manipulations. One very interesting manipulation type that we're working on is face morphing, where you take images of two persons and you merge them into a single image. And the interesting thing is that the single image looks like both the individuals.
Oh.
Yeah, this is possible. If you select people that are already a little bit similar, you can make very convincing face morphs. If a person would apply for a passport using this picture, then two persons could travel with a single passport. So the scenario is a criminal and an accomplice make this nice morph. The accomplice asks for the passport and the criminal can travel with a completely valid passport. So if you look at the computer vision and biometrics specialization, you need knowledge about pattern recognition, machine learning, probably deep learning, image processing in general, and biometrics. Now, for those we have 4 compulsory courses. The first course is the basics on computer vision. The second is an advanced course on computer vision and pattern recognition. The third one is introduction to biometrics, and the fourth one is machine learning.
You learn about all the basics of machine learning. For example, support vector machines, and then decision trees and all those stuffs. And then you slowly start learning about the neural networks. Then you learn about deep neural networks. And it's something to do with mathematics as well.
So all the basic concepts and all the basic working of how artificial intelligence works and how a machine learns stuff, how a machine becomes intelligent.
The course goes into basic machine learning and pattern recognition things that for example, classification. You have two types of objects, let's say a square and a round object. You have images of it, then you have a classification problem. You have to decide from an image which is which. And there are many different ways to handle that. There are classical ways where you try to extract certain deep features from an image. This could be, you could try to detect corners. Well, if everything is correct, if you have the square, you would have 4 corners, and for the circle, you would have no corners. You could also use other types of techniques like deep learning. Now, this takes a lot of training data, and it takes a lot of time as well, and it takes a lot of computing power. You can take many different types of objects, planes, cars, clouds, flowers, whatever, so 1,000 different classes. You can train a network to recognize all those things, and then you can say, okay, now I have a more or less general network, and if I want to use it for a new type of object to recognize it, I can basically cut off the last bit and then only train a very small part that is based on the type of features that in the end that this network has learned to extract from the images. Now, this is the deep learning type of machine learning.
But then in this course, are the students then like learning what is all out there, or are they also experiencing this themselves? Like, do they get like images and like try out different approaches? What works?
So it's again a bit of both. So of course there's a lot of material, and this is a more classical course with teaching, also frontal teaching, good old-fashioned frontal teaching. But there are also assignments where students, for let's say pre-cooked situations, can develop their own answers to it. But that is more like it's an assignment like you have in many other courses. So if you look at the Introduction to Biometrics course, it's basically getting to know the basics. Yeah? So what kind of what we call modalities are there? And modalities are like face recognition, fingerprint recognition, finger vein recognition, iris, all kinds of things.
Yeah.
And how to evaluate biometric systems. What are the problems with biometric systems? So also, for example, the manipulation and attacks are addressed. So we have 2 compulsory courses in computer vision.
Yeah.
Now the first course, the basic course, is given by another group. So we borrow it. And the other course we give ourselves, the advanced course.
There are assignments apart from the projects. Like we have to do a final project, and then it's like you place a virtual advertisement in a playground.
My favorite course was the Advanced Computer Vision. I was able to choose my own project there, and I chose a project on facial inpainting on images. So it's basically like choosing facial images, and if you know about like historical images or images that are like so treasured or valuable, like they tend to fade with time or they tend to get damaged with time. That's where the inpainting process comes in. So that's a technique to fill in the missing information in an image.
You learn about the eigenvectors, and then you also learn about deep learning stuff.
Not only did the inpainted images look very original and real, also that I was able to have a new metric developed for evaluating the inpainted quality of the facial images. So that was the very interesting part for me. I did that as a team project, and we were very happy with it. We also were able to present that as a poster at a small conference, and many people were interested in it, and we even got a small prize for it. So we were very happy with the subject.
There is a first part with some lectures, so that's where they get some extra information, and it's more like an overview of what is available, because they have to learn to read real scientific papers and use the results from scientific papers in their own projects. So it's more like an overview of what is available, and they have to find the information in the end themselves. The second part is then really the hands-on thing, as you call it, and they have to develop a system by themselves in a group. Apart from those 4 compulsory courses, there are also a bunch of other courses that can help you. For example, there are courses on numerical optimization, etc. An advanced course on programming can really help you, because there's quite a bit of development in here. There are courses that go deeper into deep learning. There are courses that are more directed at embedded systems.
It's very flexible and it's very diverse. If there is something you come up with yourself, like you come up with a own project, or you have a different idea than what's given there, you are free to make that as a course. You can talk with the program people, you can talk with the teachers.
They are also friendly. I think most of the teachers from this group are really friendly with the students. They're not like kind of what do you say, they're on the top level, or they're like nothing like that. There's no hierarchy. Yeah. Like you can just talk to them freely.
I had the complete freedom to do the courses which I liked. So each and every course that I did, that's out of interest, and that's something which I liked. And even from my project, so right now I'm doing my master thesis, so the thesis project also, it's a complete mix of whatever I like. So that's the reason I like it a lot here.
First year is full of courses, 60 ECs. The second year consists of an internship of 20 ECs and the master's assignment of 40 ECs. Now, students come to me and ask me, where can I do an interesting internship on computer vision and biometrics?
Yeah.
And unfortunately, I have quite a long list of companies from the past that I had some good experiences with. And those encompass, for example, ASML, the Dutch Post, which is interesting. They also use computer vision. TNO, very well known, and many others. Also local companies here. For example, also in agriculture is very nice.
Really?
All kinds of computer vision applications in agriculture. We had a very intriguing master's subject on 3D face recognition of cows, for example. The traditional way to recognize cows is those labels on the ears, but they are not really animal friendly.
No.
And they can get dirty, they can get lost. And this student actually really built a 3D system with 2 3D cameras from different angles that observed the cows and implemented this thing. And it was actually very accurate.
Really?
Yeah, it had an almost 100% recognition rate for cows,
Whoa.
just on the shape of the head of the cow.
Whoa.
This was also presented at a conference, by the way.
And maybe we can talk a bit more about the thesis, how that works. Do people normally do that at the university or also at companies, or?
Yeah, that also differs between the different programs. Most of the electrical engineering students, for example, they do their assignments, master's assignments, at the university. So that would be simply in our group. And they would sit in a lab like this and do their work, develop sensors or so. If you look, for example, at this small card, this is in the framework of a self-driving card challenge. 2 master students worked on this, and they built basically the card and all the electronics to control it. And their assignment was, if you put this card on a track, and the track should have some lines like a normal road, the card should be able to follow the track all by itself.
Yeah.
And if there is a curve, it should take the curve, and it should precisely control the curve.
So we had this camera setup built on it first. So it's a hobby purpose card rebuilt into the card we have now. And we implemented the basic communication network. It's called as a CAN communication network. So it's found in the conventional cars.
Or when you talk about autonomous car, those cars have been built with some of the advanced sensors such as radar, LiDARs, IMUs, GPS. So all those sensors have been there in autonomous cars. But with the car that we have built now, we don't have any of those sensors, but except 3 cameras. Yeah, basically we consider those cameras as a stereo camera setup. Stereo cameras are like, in simple words, like it's like our eyes. Like we also have kind of a stereo pads wherein we could estimate the positions of the objects.
You can also drive it using the remote control, but we have programmed the RC such that it acts as an emergency stop button.
This challenge that I talked about is organized by the Dutch RDW, so the Dutch Vehicle Authority. And they really are interested, of course, in the weaknesses of those self-driving systems, because they have to basically approve those cars.
The challenge that we face during running these autonomous cars are the weather conditions and the temperatures. So that's really a big challenge for us.
And when I implemented that and when it was working, so it was really exciting. It was really giving a satisfying feel.
The whole master's thesis normally consists of 3 parts. The first part being this divergence, so literature research, look around what kind of solutions exist. They have to make a decision. That means that there's a formulation of research questions, as we say. And they should have a good base of the knowledge about methods that exist.
Yeah.
But there's a clean view on what is to be done next. And that's the more practical part in many cases. implementation of algorithms or building of certain systems, etc. So that's the bulk also of the whole assignment. And of course, at the end, there's the reporting part. Now, I always tell students, don't postpone reporting till the very end, because it's a guaranteed recipe for stress. But start writing right from the beginning. So if you have your literature part, how nice it would be if you already have finished that for your report.
What are the kind of tools or equipment that you can find here in the lab, like to work on your project? Are there some nice things that you can mention about that?
Yeah, as a computer vision and biometrics lab, of course we have cameras. We have quite a lot of different cameras. We also, because a lot of the analysis of these images is done using deep learning, we have a high performance cluster that allows us to train quite advanced and complex deep learning systems. So this is really a cluster of PCs with lots of GPUs, graphical processing units, that are used for deep learning and training, and we have a big one. Furthermore, we build things, yeah? So we build sensors, etc., sensor systems, and we build also those phantoms, for example. And for that we have several 3D printers. You can also see one in the back here. We use those, and students use them, and sometimes it's just for printing the housing of a device, and sometimes it's like printing a phantom. So we have those things as well, and we have electronic equipment. Behind this desk there is a facility to solder printed circuit boards, for example. Oh, and there's one more. Let's see if I can. Yeah, I can show one more. Can I move?
Yeah,
okay. Yeah. Sometimes you need faces and you want to do things with them. So, for example, if you want to know very specific positions on faces, you can either draw dots. Another thing that we sometimes use is to push pins in it, and that's not very wise to do with real faces. So this is a very patient guinea pig for us. We also have other types of faces. So this is a 3D printed in color face. And we can use this as well because we know that this face will always have the same expression. So one kind of variability is switched off, which in research can be very useful. Because otherwise you don't know why, let's say, a system did not recognize the face because it had a different expression, because it had a different hairdo or whatever. So we use things like this too. These are all also tools. In the area of computer vision, there are quite a lot of jobs. I mentioned already agriculture, students going to ASML because also chips need inspection using computer vision. Quite a lot ending up in all kinds of medical computer vision, sometimes at universities or hospitals, academic hospitals. For example, the Netherlands Forensics Institute needs people that can analyze images of criminals. And there is the possibility of an academic career. You can continue after your master's with a PhD. And a PhD basically is a deepening research of 4 years in a specific subject, and you become a self-contained researcher in that way in the 4 years.
Why is this specialization an electrical engineering specialization?
For example, with my small-scale card, if you only have knowledge about computer science, then you wouldn't have been able to build up those electronic circuits and stuffs. I think the knowledge that I had like with electrical engineering really helped me out to build the small-scale card. And then with just programming, it's not really possible for me to build such a kind of small-scale card. It's the collection of everything. It's about electronics, programming, mechanical, mechatronic systems.
The atmosphere is good because, as I said, it's a diverse program. You have a lot of specializations, and I have friends from many other specializations. So you get to learn more, as well as like you get to have a bit of fun. So at times, like when you are too stressed up or you are so involved in studying, there can be a friend from other specialization who is not having any stress at the moment and who can help you. And also the people, I mean the program persons are very supporting. The teachers, the faculty, the administrative staff, all of them are very supporting. So even if you are having any situation that does not go well, or if you're having if you're too stressed up, or any difficulties that come specifically for you, you can immediately go there, seek support, and they'll help you in the best possible way they can.
And do you enjoy doing the program?
Yeah, I very much enjoyed the program. That's because they do have a lot of interesting subjects, and as well as the teachers are also so motivating, and I really love doing this specialization at the University of Twente.